All right, guys, today we're going to talk about greatest common factor, or GCF, which is probably something you've heard of before. So go ahead and put your name and the date on the paper. All right, we all should know by now, because we've done this definition a few times, that a factor is a number that can be multiplied to get another number. To have something that is common means to be shared or both have. So our greatest common factor is going to be a factor that two numbers have, and the fact that it's greatest is going to mean it's the largest factor that two numbers have in common or both share. So to find our greatest common factor, or GCF as we are going to call it, there's two different ways. And the first way is the one you guys are probably most familiar with. That is by listing factors. In order to do that, you need to follow these steps. List all the factors of each number. So I'm going to do that down here. So my first number is 18. I'm going to show you a simple way to list factors so that you don't miss out on anything. 1 times 18. Can 2 go 18? Yes, it's even. So I'm going to do 2 times 9. Can 3 go into 18? Let's see. 1 plus 8, that's 9. 9 is divisible by 3, so 3 does go into it. Goes in 6 times. Can 4 go into 18? Well, 4 times 4 is 16. 4 times 5 is 20, so no. Can 5 go into 18? I don't think so. It does not end in a 5 or a 0. Can 6 go into 18? Well, 2 and 3 can, so 6 can as well. But I already have 6 written down, so I should know that these are all the factors of 18. Now, I'm going to switch my colors here and do factors of 36. We're going to do the same thing. We know 1 times 36. All right, can 2 go into it? Well, it's an even number, isn't it? So it's going to be 2 times 18. Can 3 go into it? 3 plus 6 is 9, so yes, 3 can go into it. And that's going to be 3 times 13. Nope. 3 times 12. What am I doing? Can 4 go into it? Well, we should know off the top of our head that that's a fact family. 4 times 9. Can 5? Well, it doesn't end in a 5 or a 0, so 5 cannot. Can 6 go into it? Yes, we know that's actually the square of 6. Let's write 6 times 6. Right now, I'm already noticing that 6 and 6 are both over here, which means nothing else is going to go into this because it would have to go down here and then I'd have larger numbers. So everything that 36 can be divisible by is right here. So now that I've listed my factors, I'm going to circle the ones they have in common. 1, 2, 3, 18, 9, and 6. All right, the greatest number that is circled is going to be the GCF. So using this method, my GCF is going to be 18. Now, here's the problem with using listing factors to find GCF, is that sometimes we forget a factor pair, and that can mess us up because it might cause us not to have the largest factor written down. So today we're going to learn about finding GCF using what is called prime factorization, which some of you might have seen before. And to do prime factorization, we're going to follow some steps. And I know for a fact you've seen these steps before. We're going to make what is called factor trees to find our prime factorization. And to find prime factorization, what we're looking for is all the factors that make up a number that are prime. So we're going to make a factor tree, and at the top of our tree is going to be our number. So we're going to start off with 18. We're going to make 2 stems coming off of 18, and we're going to pick any 2 numbers to multiply by to get 18. Let's do 3 and 6. I'm going to circle now any factors that are primes, because that's where my tree is going to stop. So my tree is going to stop here because 3 I know is a prime number when I look at my prime factor sheet. But 6 is not, so this one has to keep going. To get 6, I do 2 times 3. Those are both prime, so I'm going to circle them. So the prime factorization of 18 is 2 times 3 times 3. all I did was break this down until I had only prime numbers at the bottom, and then I wrote them as a multiplication sentence right here. If I multiply this out, 2 times 3 is 6, 6 times 3 equals 18. It does not matter what numbers you start with up here, you would have ended up with the same no matter what. Let me show you over here to the side. Say I wanted to do 18, but instead of 3 and 6, I'm going to start with 9 times 2. 2 is prime, so I'm going to circle it. 9, there's only one way to get 9, that's 3 times 3. I still end up with 2 times 3 times 3. So it doesn't matter what you start with down here, you're going to end up with the same answers. So now we got to find the prime factorization for our second number, and again I'm going to switch just so that it doesn't run together. All right, so 36, again, it doesn't matter what I want to start off with. Let's go ahead and start off with 3 times 12. 3 is prime, so I'm going to circle it. It's going to have a little leaf there. 12 is not prime, so I have to keep going. Any two numbers, I'm going to pick 3 and 4. 3 is prime, so I'm going to circle it. 4 is not, so I have to keep going. 2 times 2. Those are both prime, so I'm going to circle them both. So my prime factorization for 36 is the same as saying 2 times 2 times 3 times 3. You don't have to write them in order like I do. I do that to help me when I get to this second step. So this is called using a factor tree to find prime factorization. Now that I have done that, what I'm going to do is I'm going to circle numbers that they have in common, but I'm only going to do them in pairs. And my pairs have to be 1 in each number. I'll show you what that means. So this is a pair. I have a 2 and a 2 here. And I have a 3 and a 3. And a 3 and a 3. Remember, a pair only has 2 numbers in it. So this extra 2 right here, I can't use that. Now that I have my pairs, what I'm going to do is I'm going to multiply each number represented by a pair to find my GCF. To do that, I'm going to multiply 1 from this pair, so I'm going to multiply 2. 1 from this pair, 3, and 1 from this pair, 3. So my GCF is going to equal 2 times 3 times 3, which we should know is 18. And since that's my answer, I'm actually going to put it in a nice box so that I know, because I have a lot going on here. So go ahead and pause your video, and you're going to try to find this 2 different ways. First by listing, and then by factor trees. Start with listing because that is what I'm going to start with. All right. Okay, guys. If you've done this by listing, you would know 25. I can do 1 times 25. 2 doesn't go into it. 3 doesn't go into it. 4 doesn't go into it. But 5 does. It's 5 times 5. And since I have a 5 on both sides, I know that's all of my factors. Now let's do 100. 1 times 100, it's even, so 2 goes into it 50 times. 3 does not. 4 does. 4 quarters in a dollar. Ends in a 0, so 5 can go into it 20 times. 6 cannot, because it's not divisible by 2 and 3. 7 doesn't. 8 doesn't. 9 doesn't. But it ends in a 0, so I know 10 does. And since I have a 10 on both sides, that means I know I'm at the end of my line. So they have a 1 in common. They have the 25 in common. They have a 5 in common. So according to listing, my GCF should be 25. All right, but we also have to do that with a factor tree. So if you haven't paused and done the factor tree, go ahead and pause now. Okay, factor tree for 25, there's only one way I can do it. I don't want to start off with 1 times 25 because it's not going to help me out at all. That's one trick I did not tell you. So I'm going to start off with the only other thing I can use, which is 5 times 5. And both of those are prime. So I know to get 25, I have 5 times 5. Now I'm going to do 100. Let's do 25 times 4. Neither of those is prime, so I'm going to start off with just the 25. To get 25, I do 5 times 5, which is prime. I'm circle both of those. Now I need to go back and do this 4. 2 times 2. I can circle those, and since I'm down to prime numbers, I can be done. So to get 100, I have 2 times 2 times 5 times 5. What do I have to do next? Circle my pairs. Okay. They both have a... Sorry, my paper was moving. I was trying to hold with my elbow. They both have a 5. And they both have this 5. Now, I have a lot of you who probably wanted to circle these 2s because that's a pair of 2s. The only reason I can't circle these 2s is because they don't have it in common. In order to have it in common, I'd have to have one at the top and one at the bottom, which I do not. So these 2 5s are my only pairs that they have in common. So now I'm going to use that to find my GCF. My GCF is going to be one of these 5s times one of these 5s, which equals 25. All right, your practice problems are actually on the back today. There are 6 of them. You have room at the bottom to work if you need to, except for you wouldn't use a permanent marker, so yours wouldn't have bled through. Please, please, please try it both ways. If you don't try it both ways, you will not be counted as completed. I'll see you guys tomorrow.